Hello class, today we're going to talk about section 8.5 and 8.6, which involves quadratic equations again. This is going to be a 2-day lesson combining these sections. We're going to talk about the special cases today, and then tomorrow we will talk about choosing a method. Your book combines both of these, but I think it makes sense to look at special cases first and then talk about choosing a method. So, by the end of today's lesson, you will be able to factor using difference of squares, factor using perfect square trinomials, and solve special cases using the square root property. So when we are looking at difference of squares, this is two perfect squares being separated by a subtraction sign. So we got a squared minus b squared. Both of those are perfect squares because we can take the square roots of those numbers, and they are being subtracted. The factored form is going to be a minus b, a plus b. So, 3 things to check when you are looking for this particular special case. First, is it 2 terms and are they being subtracted? Second, can you take the square root of the first term? And last, can you take the square root of the second term? So, looking at this example, we have 2 terms being subtracted. So that takes care of check 1. Check 2, can I take the square root? 49 can be taken the square root and we get 7. X squared can be taken the square root and we get x. Same thing with the second term. The square root of 25 is 5 and the square root of y squared is y. So that means for our final answer we have 7x minus 5y, and for our second part of the answer 7x plus 5y. So we can take the square root of each of the terms and that square root value becomes the answer. Go ahead and try this one on your own. 2 terms, we can take the square root of both, so I get 11 minus 2b and 11 plus 2b. We can also go through and solve these problems. Remembering when we are solving quadratics, we want to have it equal to 0. So I'm going to subtract 100 from both sides, and I get 25w squared minus 100 is equal to 0. Now, since we have 2 terms being subtracted, we want to check for square roots. 25 can be square rooted, as can w squared, and we get 5w. 100 we can take the square root of and get 10. So now we're going to take our factors, 5w minus 10 and 5w plus 10. And those are going to get set equal to 0. Similar to section 3 and section 4 of this chapter, we're now going to set each piece equal to 0. So 5w minus 10 equals 0, 5w plus 10 is equal to 0. Solving both of those, I'm going to want to, for the first one, add 10 to both sides. So I have 5w is equal to 10, and divide by 5, giving me a first answer of w is equal to 2. On the other side, starting by subtracting 10, so 5w is equal to negative 10. Dividing by 5, I get w is equal to negative 2. So I still get 2 answers. We are just going to use this unique factoring method for this particular type of problem. Go ahead and try this one on your own. Square rooting 49w squared and 1, you get 7w minus 1, 7w plus 1. Setting each of those factors equal to 0, you get 1/7 and negative 1/7. Again, remember with the fractions, we want to leave them in fraction, not decimal form. Second thing we have to cover is the perfect square trinomial, which is a trinomial that is a square of a binomial. So it's either going to be a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, and that is going to come from either a plus b squared or a minus b squared. Again, there are 3 things to check. First, is the first term of our trinomial a perfect square? So can we take the square root? Second, is the last or the third term a perfect square? And third, we want to check to see if that middle term is equal to 2 times ab or negative 2 times ab. I'll go over what these mean a little bit more specifically with this next example. So we're looking. The first thing I want to check out is, can I take the square root of the first term? The square root of 169 is 13, and the square root of x squared is x. So step 1 checks out. Then I move to the third term and I say, can I take the square root of 4? The answer is yes. The 2. So now we are looking to check out this middle piece. So it either needs to be 2 times 13x times 2 or negative 2 times 13x times 2. This 2 or negative 2 in the front comes from this formula on the previous page, 2 times AB or negative 2 times AB. So we're looking and we either get 52x or negative 52x squared. Since our middle term is 52x squared, we're going to go ahead and say that checks out. So then for our answer, we have 13x minus 2, and that value is squared. So what that is essentially saying is 13x minus 2, 13x minus 2 are our factors, but we don't need to write out that second factor pair. We just need to write squared. If it had been a positive 52 here, then this first piece would have checked out, and that would be a plus for the final answer. But since we started with subtraction, that answer is going to be subtraction. Go ahead and try this one on your own. Factoring, we get x and 4 for those square roots. Double checking, we get 2 times x times 4, which is 8x. So our final answer is x plus 4 squared. We're going to check this one out, taking the square root of the front. We get 3x. The square root of the back, we get 2. Since it's a negative in the middle, I'm going to check by doing negative 2 times 3x plus 2, which is going to give me negative 12x. That does not check out with our middle term. So again, like I gave an example in the last section, this is what we're going to call prime. It means that it can't be split up into factors. So this is an example of a prime polynomial where we can use the perfect square method. One thing that is unique to these perfect square problems is we can use the square root property to solve. So we can take the square root of both sides of the equation. For example, with this one, x squared is equal to 25. Our answer would be x is equal to 5, and x is equal to negative 5. So we have our two options for answers because we can take the square root of both sides. So what we can do with these perfect square trinomials, again, we want to check out, can I take the square root of the first term? Yes. So I get 3n. Can I take the square root of the back term? Yes. That's 4. The middle part, since we have a positive, I'm going to check 2 times 3n, which is 6n, times 4, which is 24n. So that means we can factor this into a perfect square, which gives me 3n plus 4 squared is equal to 25. This is where this perfect square principle comes in. Since I have something that's squared over here and something I can take the square root of over here, I'm going to take the square root of both sides. Taking the square root of the first sides just cancels out the squared. So the square root cancels out the squared, and I'm left with 3n plus 4. The square root of 25 is either 5, or our second option is that it is equal to negative 5. Now I'm going to go ahead and solve both of these cases just like I did when it's set equal to 0. So I'm going to subtract 4 from both sides. 3n is equal to 1. Dividing by 3, I get my first answer of n is equal to 1/3. Again, leaving the fractions in fraction form. Second case, subtracting 4 from both sides gives me 3n is equal to negative 9. Dividing by 3, I end up with n is equal to negative 3. So again, we still get our two answers, but because both of these sides can be square rooted, I do not need to go through and take to set it equal to 0. Go ahead and try this one on your own. Square root of the first and the last term check out, as does the middle value. So I have y minus 4 squared is equal to 81. Taking the square roots of both sides there, I end up with y minus 4 is equal to 9, or y minus 4 is equal to negative 9. So our two answers end up being 13 or negative 5. If you have questions about this or anything else from the lesson, please let me know when you get to class.